Okay, so hi everyone. My name is Jessie Stafford, and I am here representing AI Futures. I'm really excited to kick off 2024. I know it says 23. I don't think we're all used to the year yet, so forgive us for that typo there. But we are excited to introduce Adam Hunt, who is a graduate student at Carnegie Mellon, and he is going to be doing his topic on reinforcement learning for cyber deception. Before he does get started, we did want to do an introduction of AI Futures because I do believe a majority of you have never heard of us, and maybe you did for the first time through Handshake. So welcome, we're excited to have you. So just to give you a background on AI Futures, we are a program that is supported by the Department of Defense to help them bring in civilian workers across their several different entities in the United States. So Air Force, Marines, Army, oh my gosh, the Army, Air Force, Marines, things of that nature that you would hear every day. But what we have found is that a lot of civilians don't understand or know that you can actually work for the Department of Defense and not be a soldier. So we are here to support you in those efforts. We have a great team on our student outreach side. Markham Pfeiffer, he is here to support you in terms of being able to review your resume, give you recommendations that are commonly found across working for the federal government. He does take a look at your digital and social presence just to make sure everything looks as tightly put together as possible. And then as well as he's there to give you some insight into overall interviews. And if you want to have that one-on-one attention to figure out, what are the best ways to answer certain questions that are commonly posed, he is also a great resource. So there is a QR code in front of you that if you want to scan to schedule a time to speak with Markham. Beyond that point for that student building for your resume process, I work alongside my coworker, Maddie, directly with the Department of Defense to understand what internships, fellowships, and scholarship opportunities and full-time are there, and being able to essentially match make you with those. So it's not a shoe and it's not a guarantee that you'll receive a position in the Department of Defense, but it is certainly someone else who is in your corner to help you guide through that process. And we've actually seen students who've been able to accept those positions or internship opportunities. So we'll put the slide back up at the end of Adam's talk, but really what you're here to do is hear him talk. So I'll go ahead and pass the mic over to him.
Thanks so much, Jessie. Let me see if I can share my screen. Perfect. Okay, are y'all able to hear me and see my screen okay?
Yeah, I can hear you and I can see the screen.
I can also see it.
Yes, it looks good.
Awesome. Okay, let's jump right in then. So today we'll be talking about reinforcement learning for cyber deception. And I am so excited to talk about this subject because I think it's something that's pretty cool. And I don't know about you guys, but for me, I have a hard time listening to someone speak until I know a little bit about them. So I'll tell you a little bit about myself, then we'll jump into the reinforcement learning for cyber deception. And then at the end, I just want to share a few quick tips for breaking into cyber. There's a lot of different jobs y'all might be interested in, but that's kind of my field. So I wanted to share about that in case it's interesting to anyone. So I'll do that a little bit at the end. But here's a little bit about me. My name is Adam Hunt. I'm from St. George, Utah, which looks like this. It's a beautiful city in the southwest of Utah, a couple hours away from Las Vegas. I'm a big fan of outdoor activities. That picture is not me, but imagine if it was. That's such a cool climb down there. So anything out under the sun, I'm very happy doing. I did my undergrad at Utah Tech University there in St. George, which is a beautiful campus. And then I worked a few different tech jobs, which I'll talk about at the very end. but I spent a couple years as a software engineer at a place where we made call center software, and I made the data analytics software for that company. And yeah, then I went on after that to do some research and in quantum computing and cryptography, and helped make a new course for that at Utah Tech, and then helped teach it. Then I saw someone say bonsoir in the chat. After that, I took a couple years off and had a wonderful adventure in France before coming back to Pittsburgh, where I started my studies at Carnegie Mellon. And I'm a master's student here studying information security. That's where my background, I have a little bit of background in AI and ML, but mostly in cyber. So that's what I'm specializing in here, specifically cyber operations. And it's been a wonderful time here so far. There's a lot of great research going on here and many opportunities. But I'd love to tell you guys about some research that I'm working on now, applying reinforcement learning to a cyber defense technique called cyber deception. I love this quote from The Art of War. It says, "All warfare is based on deception. Hence, when we are able to attack, we must seem unable. When using our forces, we must appear inactive. When we are near, we must make the enemy believe we are far away. When far away, we must make him believe we are near." And this is a very important concept in cybersecurity because traditionally, the attacker role is much simpler. That's the role I've tended towards in the past with my studies, but it's because if you're a defender, you have to defend an entire system. You have to make sure that there's not a single hole, a single vulnerability. Otherwise, someone might come in and take the whole thing down. So the attacker has this advantage where they just need to find one weakness, while the defender has to constantly secure this whole system. And for the defender, that means I need to lock things down more. I need to shut down services. I need to do things that make life a lot harder for everybody that uses the computer systems. People don't generally like the cybersecurity guys in an organization because everything they do costs money and makes life harder. So it's a tough job being a defender. Looking forward into ways that you can kind of take back this advantage from the attackers. Cyber deception is a really powerful way to do this. It's an active technique where we're able to impose cost on the attacker. We're able to learn about them, and we're able to make them spend a lot of time doing what they don't want to do. Continuing with this warfare analogy a little bit from The Art of War, cyber, we can see that as another terrain. It might not be like mountains. It's more like a constellation of IP addresses in a network with connected systems, and those might be routers or people's desktops, IoT devices, cyber physical systems controlling our electricity or our water. And all of these things are part of this cyber terrain. And this is the terrain we work in when we're talking about cyber deception. So we're going to talk about all these techniques, and you can be imagining this network of connected systems. There are a lot of different cyber deception techniques. Here are 3 categories. It doesn't cover everything, and there are lots of different subcategories here. But we have moving target defense, which involves things like reconfiguring the network. Maybe we put an intrusion detection system in a new place. But the goal is that an attacker is coming in to attack us. And if our network stays static, it makes it way too easy for them. They're able to scan our network. They know where everything is. They make a move. They make another move. They can go through their path without any problem. With moving target defense, we changed that. So they thought they knew where the intrusion detection systems were. Well, we just moved those. So now they have a higher chance of getting caught. They thought they knew how everything was laid out, where it was positioned. Well, we just dynamically reconfigured the whole network, and now they're confused. They don't know where to go. Obfuscation. So this is where we hide true data, or we introduce fake data. Cyber attacks, it's really a question of data. So they're looking at our system, they're looking at what data is available, and they're trying to decide, where do I want to go next? They have some objective. So maybe they think, this computer, this looks like a database system, this looks like where all of the good information would be. Let me go and attack that. But with obfuscation, we can make things look a little different. So maybe they think this is a very valuable piece of equipment with all the data they could want, but it isn't really. We've made it look like another system, and now everything looks the same, or something that isn't a database looks like a database. The final category that is applicable to us today, in general, we call it HoneyX. You might have heard of things like honeypots or honey nets, but these are systems that we add in that they don't have any real functionality. They're just there to take time. So an attacker will see this, they'll be like, oh, this is a vulnerable system. I should go attack this system. Maybe there's something good. And then they go in and they spend time on it. And while they're doing that, there's nothing on the system. It's just something we've set up for them. We're able to buy time to go in and detect them. We're able to see what they're doing. So maybe they're going to put a piece of malware on the system. Now that we have that, we can take it and we can analyze it. We might be able to get hints into who these people are and how they operate, which will allow us later to go and maybe perform countermeasures. We can contact law enforcement and have them go stop these people. It can also just buy us the time we need to detect an attacker and get them out of our network. So these are very powerful techniques that let the defense take a more active and even offensive approach, which gives them a much greater advantage. But this is hard to do while an attacker is coming at you. Maybe you can do these things statically. I can set up a honeypot in advance, but that could be easy to detect. What we want to do is make this a dynamic system where as soon as an attacker gets in, the network is actively working against them. And so to do this, we want to create an agent that's able to see what is going on in the network and take actions there so that it can, in real time, play against the hacker. And so for this, we use reinforcement learning to create an ML model that will define the policy for these actions we're taking. We can see reinforcement learning, many examples in games. So reinforcement learning agents have learned to play Go and chess and Mario and Flappy Bird, as you see here, and even complicated games like Dota 2, which is kind of incredible. But RL algorithms, they work by letting an agent learn in the environment it's going to play in. So while other forms of machine learning might just hand a lot of data to an algorithm and say, this is your input, this is what your output should be, and then we just give it lots of copies of that so it can learn what its output should be from its input. RL allows an algorithm to go into an environment and learn just from interacting with it naturally. And this works very well for games because in a game you don't necessarily have, a terabyte of data where you have all of the correct outputs for specific inputs. What you start with is just an environment, and you want to be able to throw an agent into this environment and have it learn what to do. And so for that purpose, we want to turn this network defense with cyber deception, we want to turn it into a game that an RL agent can learn how to play. And this is one of the big problems with applying machine learning is we need to be able to formulate our problem in a way that machine learning algorithms can learn. So we're using a common RL algorithm, but what's interesting here is how we create the game and how we apply this to a real network so that we can use this in the real world. So here's our adaptive cyber deception game, which is going to use some of those tactics we talked about earlier and abstract them to a higher level. And then we'll see how our RL algorithm can learn in this environment. But in this game, we have two players. The first one is the attacker, and the second one is the defender. The goal of the attacker is to steal digital assets from a network without detection. So you want to, this is the same as a hacker breaking in, and he's going to get all of the data. He wants to steal the credit cards that are stored on the database, for example. The goal of the defender is to catch the attacker before they're able to do that, before they're able to get all of that data out. The model in this game looks a little bit different for the attacker and the defender. So we'll start by looking at the attacker view. We look at this as a graph, which makes sort of intuitive sense as we're thinking of a network. But here, these individual nodes, we wouldn't think of them as computers, but we'll think of these as states within a cyber attack. So if we look at maybe V1 here, this node, that's where our attacker is starting. That's the beginning. And each edge going out of it is a possible action they could take from there. So if I start my cyber attack, maybe what I'm going to do is start with reconnaissance. So I'm going to scan a network. Maybe I'll run an Nmap scan and I'll see what ports are open on all of the computers. So that action of scanning would be like one of these edges. And if it is successful, then I will transit to the next node in this network. And that node would represent the state in which I have the knowledge about the open ports on the network. You can see here that there are solid and dotted edges, and some of them are notated with P equals 0.2, for example. And that means that if an attacker tries to take this edge, there's a 20% chance that it will work. Because in the realm of cyber, you may try an attack, but it's not necessarily going to work. You may try to scan something, but you won't necessarily get the information you wanted. Maybe it's an attack that you don't have the skills for, you don't have the tools for, so it might not necessarily work. So whenever we try to take an action, we have a chance of succeeding. The dotted lines, you'll see one of them has P equals 0, and these are fake edges. And this is part of our model here. And in our game, we're going to see that these edges can be put in to trick an attacker into trying to take an action, which is actually impossible. But in this one, we see our attacker starting at V1, and they're able to see all of the actions they could take, so all of these edges, and the nodes that it would take them to. And they see a value at each of these nodes. V1, 2, 3, and 4 are a potential value. So maybe if one of those means hacking a database server, it has a value of like 10,000. And once I get there, as the attacker, I win all of this value. So that's my goal, to go through this network. I can see one action at a time, and I can see the value I will get if I take that action. And I'm just going to keep playing, try not to get caught, because then the game will end, and I'll try to get as much value as I can. That's the attacker view. The defender view sees a little bit more. The defender can see everything the attacker does, but the whole rest of the network as well. They're able to see the values for all the nodes, everything connecting them, and they're able to tell which edges are real and which edges are fake. And we're going to see later that defenders can change what a node value looks like, but they're able to see the true node value. So that's what our attacker sees, that's what our defender sees. Defender sees a lot more. Back to our game, the attacker, each time they have a turn, they're able to make one move or to stay. So I can take one action, I can try to do one thing, and then we're going to let the defender play. So I might try to do my scan, and then the defender will come and take one of their actions. So my action as an attacker is I'm here in V1. I choose to try to take this transit, and it ends up being the solid line from V1 to V4. And maybe it works, so I get there. And that was my action. That's my turn if we're playing like a board game. Or maybe it fails. Or maybe I decide I'm going to stay put here for one turn because I feel like I might get caught if I move right now. The defender has a few more actions that they can take. So these are the deception tactics that we're talking about. And they are a little more high level, but they map onto the same things we've discussed. So in this game, they're able to hide a real edge. So one of those actions that has a non-zero probability of moving into the next state. They're able to add a fake edge. So maybe this looks like there's a port that wasn't open on a computer. There wasn't any service running on port 22, for example. We didn't have SSH, but I turn it on. So now it looks like there's a way to get into this computer. Like I should be able to take this action and get there, but really there's a 0% chance of that working. That's not going to happen. Another deception tactic they could use is modifying what those node values look like to the attacker. We said that the attacker can see the node they're going to, and they can, but what they see is not necessarily the truth. They see whatever is there or whatever the defender changes it to. And the defender can also monitor an edge. So we can see that here. Monitoring an edge might look like putting in an intrusion detection system. And now when the attacker tries to use that edge, if they try to use it, they'll be caught because we'll see them. And so these are the 4 different actions a defender can take. And they're taking these actions based on a probabilistic guess of where the attacker is. So they might not know where they are, but they have an idea maybe, and that informs our defender agent. These are their 4 actions, and if they had all the resources in the world, they would just get rid of all the real edges, add fake edges, monitor everything. But we don't allow it to do that because in the real world, that's not very realistic. So we give them a budget of how much they can do. In the real world, you can't just take down the whole network and turn it into a monitoring trap because then your network doesn't work anymore. So we use a budget to handle that. That's what the model looks like. And this is what it would be in a real network environment. And so what we've looked at before, this has already been done and we've measured it. We've used an RL agent to learn with that game, and it was able to outperform our best heuristic agents. So agents that had simple heuristics like always try to go towards the node with the best value, always try to do this. And our RL agent outperformed that. So the next step, and this is what I'll be working on this next semester, is taking this and putting it into a real world environment, which is kind of cool to think about what you're looking at here. It's like a robot, but for a network, where it's taking, you see this blue line here, is our robot it's like looking at the network. It takes in telemetry. So it's getting all of this information about what the network looks like and what's going on in it. And it takes that into its brain, the strategy box there. And that's where our policy is defined. So that's where we'll decide what to do. This checks what actions are available. And then our defender agent will actually make these actions on the network using an orchestration service. And this is, for me, this is where it gets really cool. So before we were just playing a game, but now we have this policy that is learned about how we should react, and it's going to be able to go and to actively change the network. So we'll actively add in a honeypot. So this machine that is there to kind of trap them. We can restore a computer. We can add services that weren't there, and we can try to trap this attacker as they're actively fighting against our network. So this is the agent environment that we'll be training in for the next iteration. We'll be deploying this in the cloud, and we don't want this to just work against our own attacking agents. We want to have it train against real attackers. So we are putting in real vulnerabilities. So I'm not sure if any of you have seen this website before. It's a little spooky. It's called Shodan, and they run scans over the whole internet, and they see what is running. And one of the things you can do is you can check for specific vulnerability. So if you see Shodan report, and then there's it says vuln, CVE, blah, blah, blah. So this is a known vulnerability, and Shodan has detected this on 182,000 devices in the world. And so all of these show up, and their IP addresses are made public. So attackers are able to go to this website if they want, and they can search for specific vulnerabilities, something they know how to hack, and get a list of IPs where you can go and exploit these vulnerabilities. And this is great for our purposes because we're in the counterintuitive position where we want to be attacked. So by inserting known vulnerabilities into our network environment protected by our cyber deception agent, we're able to entice attackers to come because it will be scanned by Shodan and then made public. And anyone who's automatically going through and trying to attack everybody who has CVE 2014-0160, they will automatically come in and start attacking. And once they're into the system, they will hopefully spend some more time on it, which will allow us to test our system, gain more information about these attackers, and even do things like identifying who these people are and taking countermeasures against them, which is pretty exciting. So that is the work we're doing right now in cyber deception with reinforcement learning. I'm going to take a quick foray into tips for breaking into cyber, but at the end we'll have a moment where we'll do some Q&A. So you'll be able, if you have any questions about that, we'll be able to go over them. But I thought it would be, for this audience specifically, I think a lot of us are interested in breaking into tech, getting further in our career. A lot of us are at the beginning and we're wondering what things we need to do to get further. And so I just wanted to share a little bit about the things that have worked for me. I am still a student, but I guess my only claim to fame is that I was at a job fair this last weekend with the Scholarship for Service program and had a lot of interest from government agencies. So take this for what it's worth. Maybe it helps or maybe it doesn't. But here are some things that helped me break into cyber. Certifications are super useful. It's a way you can do independent learning and have a piece of paper that shows you know how to do something, which is so important for getting your foot in the door, because otherwise an employer doesn't know if you're a security wizard or if you have no idea what you're doing. But with these, at least they can tell you've met some requirement. So I got my first tech job working in IT after I got my A+ and my Network Plus certifications. And then later on, I got my OSCP, which is a more advanced hacking certification. And that opened a lot of doors for me, including getting into a graduate program and getting offers from lots of government agencies. And these are things you can do on your own time. It doesn't matter if you're in the middle of nowhere, if you're in the most advanced university, or like me in my undergrad where I was at like some no-name college in the middle of nowhere. You can do these things and get instant recognition, and people will know that you know a little bit what you're talking about. So these are good ways to learn and to show that you know what you're doing. Another thing that has been great for me, there are scholarship programs so that you can advance your education, have it paid for, earn a stipend while you're doing it, and come out with a cyber job or a job in technology generally. So my education right now is funded by the Cyber Corps Scholarship for Service. There's also the DoD has their Cyber Scholarship Program, and with these, you're gonna leave your education with a job in hand, which is an incredible benefit. It's like you get the education, you get the job, and you're instantly into the career. So these are great opportunities. They're available at tons of different schools. So if you're looking to break in, this is another great way to do it or to advance your career further. And the final thing that's helped me is actually AI Futures. I'm here giving this presentation today because I came last semester when there was someone from like special operations technology talking. And afterwards, I talked with Markham, and he helped me out so much. He went over my whole resume and told me everywhere it was terrible and how to make it good, which was so helpful. He went over my LinkedIn and how to make that better. And then now I get, every time there's cool new job openings in the DoD, I get an email with how to apply for that, which is, with that, I mean, you have all you need to get into a career in technology. So there's really no barrier, which is kind of awesome. But that's all I have for y'all today. But I wanted to take a minute and see if there are any questions about getting into technology or about the research we're doing here on reinforcement learning for cyber deception.
Awesome. And I'm going to help you with that, Adam, so that way you don't have to scroll through chats or anything. So we're going to let Luke ask his question because he raised his hand so quickly. But for the rest of you, if you wouldn't mind dropping your questions in the chat. There are over 350 people here right now. So I'm going to just come out and say it. We will not be able to get to every question. So I apologize. But, you know, feel free. We are going to put back up our slide after the Q&A. So that way, if you want to have a similar experience to Adam in regards to one-on-one time with Markham, you'll have that chance to do so. If that QR code is being wonky, we'll drop Markham's Calendly right into the chat here. I feel like his calendar is going to blow up pretty quickly, but thank you so much. Okay, so Luke, you have your hand up. Let's go ahead and fire off with that first question.
Hello, can you hear me?
Yes.
Hi, so quick question, because I kind of study data analysis, and is there any like scholarship in terms of like on that field for like data set management or risk management? Because it's really interconnected with cybersecurity. What is your recommendation if there's like any certification or anything that can align with like getting into like working for the government, etc. like that?
Yeah. Oh yeah, for sure. So as far as scholarship programs go, like these same scholarship programs would definitely work for that. Like that is completely aligned with it. Certifications. So two that come to mind for me are CompTIA has a cybersecurity analyst one that looks more on that side of things, on this analysis side. And then there's a CISSP. I think I have that in one of the slides. Yeah, in the bottom left there, CISSP. That's another interesting one that covers that domain a little bit, and people look for that like crazy. But in my program, so here at CMU, our program offers, it's funded by it's funded by CyberCore Scholarship for Service, but I've been able to do things in like cyber risk modeling, any computer science and data analytics classes that you want, you can take and have it funded by this. I think if you're going specifically into data analytics and you're not applying it as much to the cyber side, I might look into more like programming problems that you can do, because your interviews might look more like, here's a data set, how do you do an analysis on this, and like write out your program on the board. So I think working through those problem sets can be super helpful as well. Just depending on whether you're looking more into the pure data science side or applying that in the realm of cybersecurity.
Thank you so much, Adam. Appreciate it for your time.
Yeah.
Awesome. So obviously you have a lot of great certifications and experience, and was it a financial investment that you had to just take on in order to essentially beef up your resume? I think a lot of people are curious.
That's a great question. So when I first started, I did some courses through a local tech college. And so that, because I was a student there, it made it cheaper to do my CompTIA certifications. So A+, Network Plus, Security Plus, Linux Plus, and Cybersecurity Analyst. So those ones were a little bit cheaper. Once I started getting into offensive security, I don't know if you work for some place already, they'll pay for it, but the problem is you might need it to get into it. So when COVID happened, I used my extra time that I now had and my stimulus check to pay for my OSCP. But yeah, I ended up just pouring, I don't know, a couple $1,000s into certifications, but I would say for me, it was worth it.
Yeah, definitely. Yeah, so definitely start with your university's resources if you're a current student to see what they can do to help you.
Yeah.
Awesome. Thank you. All right. So what sort of process or thinking did you use to get from a general interest in cybersecurity to your very particular research interests today?
Oh, good question. So starting with cybersecurity, I was interested more in the offensive side, so hacking and breaking into computers. And then a really cool thing being here at a research institution is that there's a lot of collaboration that goes on and a lot of interdisciplinary research. So this project, I got into it because I reached out to a professor whose class I was going to take, and I said, like, I'm interested in this sort of research. And then she came back to me with a proposal saying, hey, we need someone who knows offensive cybersecurity to come work on this project. And I had some background in AI and ML and a lot of experience in this, so it went together well. But I'm working on maybe 2 or 3 other research projects right now. And I think so I'm still, I guess, finding my final path, but I think it's cool to reach out to other people working in the field and then just take some time working with them on whatever they're working on, and then find what interests you the most and keep going with that.
Okay. And then just to kind of piggyback off of that, because reading through the questions that are being presented, if you are initially in cybersecurity and this is maybe something that you want to pursue, how do you get started?
Okay, so just like the very beginning of cybersecurity, you haven't done a lot and you want to get into it?
Yeah.
Okay. That's a great question. For me, certifications, and because I was a student, taking some classes were the beginning of that. There are so many resources online. Like if someone was taking a similar route to me where they wanted to do more of this offensive stuff, I really like Hack the Box, where you can go on and you can play through these labs, and people have walkthroughs published. So my first step was like, I found a walkthrough, I found a lab, and I just like followed exactly what they were doing. But if you can find a course either at your university or if you're not there, then online, and just start going through these and try to make sure whatever you're studying, it's something that you want to have a product at the end of it that you can show to someone. So either a certification or a project on GitHub, something like that. So you're learning through a course or a personal project, something online, and then you have something to show that you've learned it. CTFs are also great.
Awesome. And I would say too, just from the different involvements at AI Futures, we sponsor different hackathons. So if you know that your university is hosting a hackathon, if there's a cybersecurity club, those are excellent opportunities for you to tap into, because we've known students who have had zero experience with that. They go to one hackathon and they're hooked. And then that just lends itself to furthering your studies. Maybe it's a major change, whatever that pursuit may be. Just by looking at your own university resources is just so important.
I
So
love that. Yeah.
awesome. Okay, so how, as a student, how are you able to balance learning multiple languages as well as taking a step towards cybersecurity, such as working with Python?
Good question. So you can kind of have these things work together. Like if you're using Python in the cybersecurity context, it will work out well. I guess I learned programming before I got into cyber, so I was already proficient in Python, at least before I started. Some people look at cyber as like the peak of a hill, and before that you should learn like all of computer science, programming languages, and IT, and then you should get to this peak and add on like cybersecurity. And I don't think that needs to be the case. Whenever you're working through like learning a language, for example, you need to have problems that you solve with it to practice, and you can just make all of those like cybersecurity problems. So take whatever you want to learn, apply it in the domain of cybersecurity, and that's one good way to run both of those concurrently, because you'll be learning the Python you specifically need for cybersecurity.
Awesome. Thank you. Well, we are at time. So Adam, we truly appreciate the content that you were able to present on today. I think you inspired a lot of different people just by how much our chat has blown up. We are going to throw our AI Futures slide back up here. I'm going to wait for the thank yous to die down for a minute, because I'm also going to put in Markham's direct Calendly link. So if you want to schedule that one-on-one time with him. We also have our website, aifutures.us, where you can stay tuned for any future events that we are going to be having. John Orlando is our next speaker. So our registration, if it's not already on the website, it will be here shortly, where you can register for that Tech Talk. I believe it's coming up on around the 25th. Don't quote me on that. The website will tell you the truth. And then as well as follow us on Instagram, follow us on LinkedIn, follow Adam on LinkedIn. Sorry, I'm going to put you out there to continue those conversations. So we're really just excited that everyone has similar passions, that they're willing to take the time on their Friday to listen to Adam's talk. And I would be remiss to say that we also work with the Navy. My boss is a Navy veteran, so I have to plug the Navy too. So one note I want to give, though, and because I just don't want to set anyone up for false hope, in order to work for the Department of Defense, you do have to be a U.S. citizen. So I just want to be very clear on that. So if you are interested in pursuing an internship or full-time opportunity, Markham can talk you through that process too. So thank you so much. Enjoy the rest of your Friday. Adam, thank you again. Have a great weekend.
You too.
Thank you.
Thanks a lot.